And so one way to think about this is that relatively speaking, we have this small drop in price, and associated with that is going to be a large increase in the quantity demanded. And you can sort of think that this large increase in the quantity demanded is going to swamp the drop in, the negative effect of the price drop, yielding to an increase in revenue overall. Okay, so that's what's going to happen when the demand is elastic. Again, when the percentage change in quantity demanded is greater than the percentage change in price. Now let's look at the case when the elasticity of demand is less than 1. In other words, when demand is inelastic. So suppose that we're down here at a point like point B, on the inelastic portion of the demand curve. Now let's imagine that price falls by 10%, and in response, the quantity demanded increases by 5%. Okay, so again, the percentage change in quantity demanded has to be less than the percentage change in price because we're on that inelastic portion of the demand curve. What's going to happen to total expenditure? Well, again, total expenditure is just price times quantity. But now we've had price drop by 10%. We've had quantity demand increase by 5%. If you just multiply 0.90 times 1.05, that it is 0.945 times price times quantity. This coefficient on P times Q is less than 1, meaning that total revenue or total expenditure, they're the same thing, that's fallen. The total revenue has fallen. And so this is a case where we see price falling. Revenue also falls. And again, the sort of intuitive thing that I like to think about here is that, relatively speaking, you have a large drop in price and a small increase in quantity demanded. Okay, so relative price is there's going to be a large, we're thinking about a percentage drop in price that's large relative to percentage increase in quantity, and overall that negative price effect is going to dominate, it's going to sort of swamp the positive change in quantity, leading to a fall in revenue. So graphically, if it helps you to understand it, let's go ahead and go over that. Remember, and this is just meant as a really quick review, when we have these linear demand curves, the midpoint of that curve we know is unit elastic. When we're up in the region above that point, we know that demand is elastic. And when we're down at points below the midpoint, we know that demand is inelastic. So that's just a quick review of what we did last time. So deliberately here, I've chosen a point B, that's on the inelastic portion of this demand curve. Now let's imagine what's going to happen if price falls by just a little bit. So, well, actually, first let's go ahead and sort of write up or sort of shade the area that represents total revenue or total expenditure initially. All right, so revenue is just, or expenditure, is just price times quantity, which is going to be the area of this blue rectangle that I shaded in here. Now we want to see what's going to happen to total revenue when price drops by a little bit. So price falls by a little bit, for example, say to P2, and that's going to lead to an increase in the quantity demanded. And so now new revenue after, now we can shade in revenue after this price change. The area of this red rectangle is going to tell us revenue after the price drop. And what you can see is you're losing some revenue because price is now lower, and you're gaining a little bit of revenue because quantity demanded is higher. Okay, so again, you're losing some revenue because price falls, and you're gaining some revenue because the quantity demanded is larger. But what I want you to try and see here, and again, I know that what I'm about to do is very, very informal, but I sort of did a formal thing up there, but informally what I want you to try and imagine is that it looks like this drop in revenue that you're getting from the price decrease, in other words, this area kind of in between these two rectangles, this amount that you're losing out because of the price drop, looks pretty large compared to the increased revenue that you're getting because of the quantity increase. Okay, so I just want you to sort of see this kind of graphically as well. And this looked really different than the previous slide, where the revenue that we lost from the price drop looked small relative to the quantity that we were gaining because of the quantity increase. Okay, so that sort of describes so there's this relationship that whenever the elasticity of demand is greater than 1, as price falls, revenue increases, and whenever the elasticity of demand is less than 1, as price falls, revenue falls. And all of this, I think, can be sort of neatly summarized in the following graph. Okay, so again, so again, here's the picture. The top picture is just a standard demand curve. The bottom picture is we have quantity on the x-axis, and I have revenue, which I'm denoting with the letter R, on the y-axis. And what you see here is that as price drops and the quantity demanded increases, we see revenue increasing when we're on the elastic portion of the demand curve. So when price falls, revenue increases along the elastic portion of the demand curve. And on the inelastic portion of the demand curve, when price falls, revenue drops. And we can also state all of this conversely. Okay, so far I've been stating all of this in terms of prices falling, but you can also say that when you're on the inelastic portion of the demand curve, as price increases, revenue increases. Or similarly, as price increases along the elastic portion, revenue will decrease. So there's this sort of interesting complex relationship between elasticity and revenue. And this is really important, for example, when you're thinking about, revenues are a good thing for firms, and so there's going to be, to the extent to which so price changes in a market are going to increase or decrease overall revenues in that market are going to be impacted by the elasticity of demand. It's one of the reasons why we care about the elasticity of demand, because it has implications for whether or not increases and decreases in market prices are going to affect overall revenues or expenditures in the market. Okay. So questions about that? It's the relationship between elasticity and revenue is complicated. For me, you can memorize it. I like to also just do these little arrow pictures. Okay, so if I'm talking about a price decrease and I'm on the inelastic portion of the demand curve, I just know price is dropping a lot percentage-wise relative to the increase in quantity. And this helps me just sort of see, okay, well, if I've got a small increase in quantity, a big drop in price, I know that revenue is going to fall. So you can kind of work through it intuitively as well. Okay. So questions about that? I know it can be kind of a confusing topic. Yeah.
Does that mean it's always the most efficient decision for a firm or an individual to pick the unit elastic price when they're setting the price for a product?
That's an interesting point. So your question is, wouldn't firms always want to go right here? Not always. So there are a couple reasons why. First is we haven't said anything about costs, and you can't really figure out profits until you know about costs. The second is that firms don't get to choose price and quantity, right? Firms, their price is set in the market, and so unless we're talking about a monopolist, in which case what I just said isn't true, but in perfectly competitive markets, which we're going to focus on in this class, firms don't get to choose price. But it is true that changes in price will affect overall expenditures or revenues in the market. But a firm can't really do anything about that. It's a good question. All right, other questions? Okay, so let's talk about the determinants of the elasticity of demand. So one of the more important determinants of the elasticity of demand are the substitution possibilities. So if there are many close substitutes for a good, then the price elasticity of demand tends to be relatively high. So at the beginning of the class, or the beginning of talking about elasticity, I was talking about bananas, and I gave them as an example of a good that is likely to have an elastic demand. The reason why I think that is probably the case is because there are lots and lots of substitutes for bananas. There are apples, there's oranges, there's pineapples, there's grapefruits, there's all kinds of other fruit that people can have besides bananas. And so a small increase in the price of bananas is going to tend to lead to a large decrease in the quantity of bananas demanded. And that's because people are just going to easily substitute into other kinds of fruit. Contrast that to something like, let's say, insulin, okay, which diabetics need. There aren't very many, I don't know for any real substitutes for insulin. I don't know a lot about diabetes medically and the treatment for it. But what I do know is that there aren't a lot of substitutes for insulin. And so you can imagine that an increase in the price of insulin is not going to lead to a very large change in the quantity of insulin demanded, because there just aren't no ability to substitute out of it. And so that's going to be a good that has a very inelastic demand. Another factor, all else equal, is a good's budget share. Okay, so the more people spend on a good, then the higher will be the price elasticity of demand, all else equal. So for example, the price of number 2 pencils could probably quadruple, and you guys, or maybe double, and you guys probably wouldn't change your demand for number 2 pencils because you don't spend that much money on them anyway. Okay, so the quantity demanded is just not going to be very sensitive to price because it doesn't take a big chunk of our budget. If you think about other higher ticket items or higher prices that have goods that have a higher price, then think about sort of gasoline, for example. People actually spend quite a bit of money, especially the low-income population. They spend quite a bit of money on gasoline. And so you might expect that the price elasticity of demand for gasoline would be relatively high, all else equal for that group. So actually, let's think about this. So compare the elasticity of demand for gasoline among the high-income population versus the low-income population. The low-income population spends a much larger fraction of their income on gasoline than does the high-income population. And so you might expect that the elasticity of demand for gasoline would be higher among the low-income population, because when the price of gasoline goes up, it affects their budgets even more severely than it does the high-income population. And so again, you can imagine that budget share is going to have a big impact on the elasticity of demand. The other thing, and actually number 3 I think really relates very much to number 1, is that the longer is the time horizon for since a price change, the higher is the price elasticity of demand. And the idea here is that the more time you have to adjust and find substitute products, the higher will be the elasticity of demand. So again, let's go back to the example of gasoline. In the short run, it might be relatively difficult to find substitutes for gasoline. But over the long run, you can imagine that more fuel-efficient cars would be introduced, that people would at least get rid of their fuel-inefficient cars and start buying hybrid cars or other kinds of cars that are more fuel-efficient. Maybe they'd start taking the bus, maybe they could buy a bicycle. But over the long term, people are going to find a way to substitute out of goods that have where you have these price increases. So you can talk about the demand for a good over the course of a day might be relatively inelastic, but the demand for a good over the course of a year might be relatively elastic. Okay? Just because we've changed the time horizon. Yeah.
Do you usually only focus on price increases? It seems like this whole concept is only for prices being
It could be price decreases as well. Okay, so if the price of bananas decreases, all of a sudden people are going to stop buying apples and oranges, and they're going to start buying bananas because bananas have become relatively cheap. If the price of insulin drops, there's still the same number of diabetics out there. It's not like people are going to be substituted. There's nothing for people to substitute, out of to start getting insulin. Demand's going to be relatively fixed. So you could talk about all of these things either way. Same here for all of these. So it's sort of, for some reason, it seems to be easier to explain the concepts using price increases, but you could easily do it with price decreases as well. Yeah.
So I guess I'm seeing that it's pretty hard to see how the price elasticity of demand is going to go up for gasoline?
So are you talking about the budget share?
Yeah, like the
example?
budget share.
So the idea here was, it really wasn't that I was talking about it going up. I don't know why I'm doing green here, but anyway, green pen. So both of these could be the demand for gasoline. But this could be the demand for people with a high income. I'll put high in quotes because I'm not really defining what high income means, and I'm not really going to define what low income means. Oops, I've done this backwards. Okay, so among the low-income population, I mean, gasoline can be an incredibly large. The low-income population can spend a relatively large fraction of their income on just buying gas, and so you can imagine that they would be more price sensitive. If the price of gasoline goes up, all of a sudden they're really getting hurt, and so they're going to be much more motivated to try and, all else equal, they're going to be much more motivated to try and find alternative ways to get around, alternatives to gasoline. Maybe they're going to take the bus more, they're going to carpool more, whatever the case may be. Whereas for the high-income population, I mean, you could imagine that the super wealthy, maybe only spending some small fraction of their income on gasoline, so the price of gasoline doubles, it just doesn't really affect them that much. And so they're going to be less incentivized to kind of find substitutes. And so they might have a more inelastic demand than the low-income population. And that's the point I was making about the budget share.
Okay.
Yeah.
When you say the price of elasticity of demand, is that the same thing as the elasticity of demand, or are they two different things?
So the price elasticity of demand is the same thing as the price elasticity of demand is more formal, but I'll also call it the elasticity of demand. So both those terms mean the same thing. Yeah.
So does this elasticity on fuel affect the prices of gas in low-income neighborhoods versus high-income neighborhoods? Like, does this elasticity make the price of gas lower in low-income neighborhoods?
We'll talk about how it might. I'm going to defer your question for a few seconds. We'll talk about how the price should be the same because there should just be one equilibrium price. That's actually what you just asked was a very complicated question because in principle, the people in the low-income neighborhood should be able to drive to the high-income neighborhood to get the gas. I mean, there really shouldn't be a different, in a perfect world, there shouldn't be a difference in the price of gasoline across these different neighborhoods. I'll leave it at that because people should be able to sort of find the cheapest gas. Having said that, I mean, there is some sort of, in reality, we do know that neighborhoods are sort of geographically segregated and there might be price differences between these different areas. But there's a lot going on there. I think that's well beyond the scope of what we're talking about in terms of elasticity. So something that I say later on might relate to this, but that's a very complicated, the issue that you brought up in terms of price differences for the same good in different geographic areas is sort of a complicated issue. Okay, other questions? All right, so let's talk about some of the real world elasticities of demand and relate them to some of the topics that we just talked about. So you can imagine that food has a relatively low elasticity of demand. And notice here how I'm sort of talking about food is just one big lump sum category. This is just food as a one unit. If I were to break food up into smaller things like cheese, chicken, Lay's potato chips, Kellogg's Corn Flakes, the elasticity of demand for any one of those particular items might be relatively high. Because Corn Flakes, for example, has lots of substitutes. But food does not have very many substitutes at all, okay? And so it shouldn't be surprising that the elasticity of demand is relatively low. Tobacco is addictive, and so naturally it has a relatively low elasticity of demand. Oil is something, it's used in gasoline, that's very, oil, gasoline, these are goods that are going to have electricity, water, these are goods that really, we are a little bit price sensitive, but they're goods that, relatively speaking, we still have a relatively low elasticity of demand for. In other words, demand is inelastic. What are goods that have an elastic demand, where the elasticity of demand is greater than 1? Motor vehicles, furniture, these are goods that tend to have a higher elasticity. Yeah.
Doesn't the elasticity of demand change on a curve? How do you give a?
That's a good. This means that at current prices, whatever the current price is, this is the elasticity of demand. So these are estimated at the current price. That's a good question. Other questions? Okay, so this is good because it just gives you a little bit of a sense of what these real world elasticities are going to look like. And I mean, there's a lot of effort that goes into try and estimate these things. There's a lot of controversy about how well you can actually estimate these elasticities, but they are very important to understand. And so, economists do go out there and try and measure these things. Okay, so in addition to the price elasticity of demand, we also sometimes talk about something called the income elasticity of demand. The income elasticity of demand is the percentage change in the quantity demanded divided by the percentage change in income. So for example, if income goes up by 1%, what's going to be the percentage change in the quantity demanded of cars? That would be the income elasticity of demand. The income elasticity of demand, notice that we did not take the absolute value of the income elasticity of demand when we were calculating it. And the reason for this is because its sign has different interpretations. So if our income goes up, so if the denominator is positive, and if the numerator is positive to quantity demanded goes up, then that's an example of a normal good. So the income elasticity of demand is going to be greater than 0 for normal goods. For example, again, we would think that if our incomes go up, the quantity of cars demanded would also go up, because cars are probably a normal good. But there are going to be other goods for which the elasticity of demand might be less than 0. So I don't know for sure if this is true, but one guess might be that as people's incomes go up, they ride the bus less. They buy cars more, they ride the bus less. That means that the income elasticity of demand for bus tickets or bus fares might actually be negative. And we don't have for the price elasticity of demand, we had that very useful formula that the price elasticity of demand is equal to 1 over the slope times price over quantity. We're not going to have some sort of neat formula like that for income elasticity of demand because we're not thinking about what's going on along a single demand curve here. We're thinking about sort of a more complicated calculation. So we really this is really how we express the income elasticity of demand. There's also something called the cross price elasticity of demand, and that just tells us by what percentage does our demand for quantity by what percentage does the quantity of good X demanded change for a 1% change in the price of good Y. So for example, if the price of bread goes up, how does that affect our demand for jelly? Which is something people usually put on bread or butter or whatever. And so how does the change in the price of one good affect our demand for another good? That's the basic idea here. Now, if the price of, let's say, bread goes up, and the quantity of how might that affect the demand for, let's say, jam? If we put jam on bread, how might the increase in the price of bread affect the demand for jam? It would go down, right? If bread gets more expensive, the price of bread goes up. People are going to buy less bread, and that means they're going to buy less jam as well. So this quantity tends to be negative for goods that are complements. So we think that jam and bread are complements, so it might be the case that we would expect the cross-price elasticity of demand to be negative. And in fact, this is really what defines whether or not goods are complements or substitutes. It's whether or not the cross-price elasticity of demand is positive or negative. So if we see an increase in the price of one good, and as a result we see a decrease in the quantity demanded of another good, then we know that those goods are complements. Now let's think about the case of, what's going to happen if the price of bread increases? What would you expect to happen to the demand for tortillas? Some people may think tortillas are a substitute for bread. Substitute for bread. I don't know how many of you feel that way, but let's imagine that you do. An increase in the price of bread, that might lead to an increase in the quantity demanded of tortillas, okay, if they're substitutes. And so we'd expect the cross-price elasticity of demand to be greater than 0 for substitutes. While we're talking about elasticity, we of course might as well talk about the elasticity of supply. What's the elasticity of supply? That's just the percentage change in the quantity supplied divided by the percentage change in price. So the elasticity of supply tells you by what percentage does the quantity supplied change for a 1% change in price. So now we're thinking about movements along the supply curve. Okay, so price goes up a little bit. By what percentage does the quantity supplied change? We have the same sort of classifications for the elasticity of supply as we did for the elasticity of demand. When the price elasticity of supply is equal to 0, we say that it's perfectly inelastic. When the elasticity of supply approaches infinity, we say that it's perfectly elastic. And when it's exactly equal to 1, we say that it's unit elastic. When the elasticity of supply is between 0 and 1, we call it inelastic. And when it's greater than 1, we say that the elasticity of supply, or we say that supply is elastic. So these are the exact same classifications that you saw for demand. Okay, so this, I'm going through this relatively quickly because this looks almost identical to the picture I drew up earlier when I was talking about how we classify the elasticity of demand. It's greater than 1 is elastic, less than 1 elastic, and then we have these special cases, perfectly inelastic, unit elastic, and perfectly elastic. And we can draw the curves, and then go ahead and draw the curves for these really extreme cases. As well. So here we have a supply curve, and what we see is that no matter what price is, the quantity supplied is exactly the same. So this is an example of perfectly inelastic supply. And similarly, over here on the right, we have an example of perfectly elastic supply. So basically, in this region, a small increase in price is going to lead to sort of an infinite change in the quantity supplied. Again, this looks exactly like what we were talking about when we were talking about demand. Now, of course, the determinants of the elasticity of supply look a little bit different than the determinants of the elasticity of demand because there's a completely set of things that determine supply and demand. So what determines the elasticity of supply? What are the conditions under which you'd expect the elasticity of supply to be relatively high? Typically, the elasticity of supply tends to be relatively high when you have flexible inputs, when the inputs are easily moved from one location to another, and when firms have a strong ability to produce substitute inputs. Okay, so the easier it is to find or make substitute inputs, the higher will be the elasticity of supply. So, for example, when I think about this, I like to think about like a pizza restaurant that makes pizza and it makes calzones. If the price of pizza suddenly goes way, way up, that restaurant can start using dough and flour and tomato sauce that it was using to make calzones to all of a sudden start making pizza. Okay, it's got readily at hand, it's got all of these ingredients that it was using to make one good that it can get its hands on to make additional pizza. Okay, so the price of pizza goes up, the restaurant's thinking to themselves, oh my gosh, how am I going to make more pizza? No problem. Stop making so many calzones, start making pizza. It's basically the same set of ingredients. You'd expect the elasticity of supply to be relatively high. Okay, so if it's easier, so when the price of a good goes up, firms want to produce more of it, and they've got to get their hands on inputs. And the easier it is for them to get their hands on those inputs, the easier it's going to be for them to produce more. So this is an example of, so when inputs are flexible and mobile and easy, when it's easy to produce substitute inputs, you'd expect elasticity of supply to be relatively high. The other case is just, again, the time horizon. So the longer the time horizon is, the more time the firm has to find additional inputs and to find substitute inputs and to get its hands on additional inputs. And therefore it can respond, has longer to respond to those price changes than in the short run. Okay, so if we're talking about the elasticity of supply over the course of a day, we might expect supply to be relatively inelastic compared to the elasticity of supply when we're talking about supply over the course of a year. Okay, so the longer is the time horizon, the greater we'd expect the elasticity of supply to be. Okay, so questions about that so far? Okay, so now let me talk about elasticity and volatility. So the general rule is that when supply and demand are relatively inelastic, prices tend to be volatile, but the quantity bought and sold in the market tends to be relatively stable. So the example I'm giving here is the California energy market. It turns out that the elasticity of demand for energy is relatively low. The demand for energy is relatively inelastic. That's why I've drawn a relatively steep demand curve here. And supply is relatively inelastic as well, at least in the short run. So just the way the electricity market works, it actually can be relatively difficult for companies to, on short notice, to just sort of increase the amount of electricity that they're producing. To bring electricity generating plants on and offline actually takes some time. It's not a trivial thing. And so we think that supply is relatively inelastic in the short run as well. So now we can imagine, let's just suppose that we're thinking about the summer months and there's some increase in the demand for electricity because maybe people want to be running their air conditioners or whatever. So you can imagine that demand shifts up. We're going to get a relatively large increase in price, but a relatively small change in the quantity, the equilibrium quantity. Okay, so this is again just the statement that when demand is relatively inelastic, prices tend to be volatile. Okay, so when supply and demand are inelastic, small changes in demand or supply are going to lead to really large price fluctuations. But that's not going to be so much the case with the quantity. And this is one of the reasons why we think gasoline prices are so volatile, because we think that gasoline is also inelastically supplied and inelastically demanded. And so small changes, small interruptions in either the supply of oil or the supply of gasoline, or small changes in people's demand for gasoline can lead to big fluctuations at the pump. And so it's really kind of hard to keep track of. It's almost like every time you go to the gas station, the price is different. And that's because this is a market where we have inelastic supply, inelastic demand, and we'd expect these prices to be volatile. And you can contrast this to a market where we think that supply and demand are relatively elastic. Okay? So here, same kind of situation, supply and demand curve. Let's imagine what would happen in this case if we had, again, sort of a small increase in demand. Now we have a relatively large increase in the equilibrium quantity, but a relatively small change in price. And so again, when supply and demand are relatively elastic, the quantity bought and sold in the market tends to be relatively volatile, but prices tend to be stable. So if you're trying to sort of understand why the price of some things tends to be relatively volatile and where the prices of other products in the market tend to be relatively stable, elasticity is a lot of the reason behind it. It offers a lot of explanation. Okay. Questions about this? Okay, by some miracle,